Hello, welcome to Injection Molding, the Whiteboard Sessions. I'm your host again, Brandon Birchmeyer. Today we're talking about how do you process an unbalanced or a family tool. Again, in the injection molding world, a lot of times things aren't perfect. There are a lot of unbalanced hot runner tools out there, and they're becoming more and more rare, but also family molds, different parts in the same tool. How do you go about process development in these scenarios? It's kind of what we're going to go through today. So let's get started. I have two examples up here. One is a true family mold. The second is an imbalanced runner system. But you could also imagine a hot runner system showing a similar situation. So first, let's talk about family tools. How do I go about process development? Again, think of this as three-stage molding. There will be three stages to this molding. However, rather than pack velocity, we're going to utilize pack pressure during a portion of the process. So let me explain. So in my first scenario here, I have a circle, a square, a small test bar, and a large test bar. Assume this runner is the same throughout, right? So this little test bar will fill first in this scenario, and this larger test bar will probably fill last. I have a cavity pressure sensor represented by the green dot and the red dot. So again, I'm going to show you how I think about developing a process for this. First thing first, go ahead and use that, high injection speed, the normal injection rate you'd be used to from your urology study. And we're going to maintain that, and we're going to transfer into that pack phase when that very first cavity to fill reaches that 90-95% full point, about where I have that green dot. So purple injection velocity, I'm going to maintain that velocity for a certain amount of time. As that velocity is maintained, my injection pressure climbs in that scenario. Okay, now I am just hitting that cavity pressure sensor, okay? It's just starting to climb. Now I'm going to transfer into my pack phase. And like I said, I'm going to use pack pressure here, not pack velocity. I'm going to use pressure because what I'm going to do is maintain a high pressure as the rest of these cavities fill out under pack pressure. What pressure to use? I actually like to use the pressure I'm at when I achieve this 90-95% full in that first cavity. So I'm going to lock that pack pressure in. Doing so causes deceleration in my screw speed. However, I'm not applying extra pressure into that first cavity to fill. That pressure is being maintained, and I'm now allowing that pressure to fill out the rest of the cavities in the family tool due to the imbalancing. You may need more or less pressure to achieve the filling out the rest of the cavities depending on how off things are. Also, the amount of time that this takes can vary as well. So you want to be cognizant of it. You want to make sure your screw doesn't stall out during this process though. If that screw completely stops moving during your pack phase here, you're going to have problems. You're not going to fill out your parts probably. So be cognizant of what's happening in your screw speed during this pressure pack phase. I'm going to maintain that pressure pack phase, and I'll have pressure, right, kind of maintained through this on that first cavity until I achieve that 90-95% full in the last cavity to fill, represented by the red dot here. So this is starting to climb. At that point in time, I'm now going to transfer into my hold phase, right, that lower pressure setting. We need to pack the parts out, cheap gate seal, things like that. And your resultant curves will look something like so for each of these cavities. Okay, so what's not happening here and could otherwise happen is we're eliminating pack velocity and trading it for pack pressure. And it has to do with sensitivity. This process, now that it's operating pressure, is sensitive to these geometric changes that are happening. Velocity is not sensitive at all. Velocity is a preordained movement of the screw that it's going to make happen kind of regardless, right? So that's why we're using pressure here. Pressure is going to be sensitive to the geometry differences in these cavities. Is there a downside to this? Sure, this is probably more susceptible to viscosity variation, things like that. But if you are flashing your tool or blowing your mold open, trying to fill out your, from your first cavities to fill, trying to fill out your last cavities to fill, this is a method or a technique you can try to employ. So that's for a family tool. Now, what about a severely imbalanced cold runner like what I have drawn up here, or a hot runner system? Same idea. Same approach. Again, we're going to be utilizing pack pressure in the process rather than a pack velocity, because pressure will be sensitive to that the changes in the geometry in the tool in real time. So again, in this process, I'm going to use that fill phase speed, right? And as I do so, in this scenario, my green dot part will fill first, much shorter fill length than the red dot part. So again, I'm going to maintain fill speed, my first transfer into my pack pressure, 95% full on that green dot, on that green circle, like so. Again, pressure will climb in the system as that's maintained. And then when I transfer into my pack pressure, I'm going to use the pressure I'm at that achieved that flow distance. Now I'm maintaining that pressure as I do deceleration of the screw. You should see, again, this pressure kind of maintain, maybe drop off a little bit. I'm going to maintain that till I get to that 95% full of my red circle, which is that part in the process. I will then transfer into my pack and hold phase in my process. What's going to happen in these multi-cavity tools that are, imbalanced, especially think hot runner tools, like a 32 cavity hot runner mold that's severely imbalanced, right? What's going to be helpful in this situation is the delta between these parts will narrow. So you'll get a better, if you were to fill these parts out completely, your imbalance distribution will narrow. What I mean by that is your normal conventional molding process. If I was to, go all the way and transfer when this was at, say, 95% full, my weight distribution may look something like that. However, taking this approach, allowing pressure to be maintained, your delta between your peak pressures and those part weights will narrow. Okay, and that's what's going to help your process. You're going to be bringing those weights narrow closer to each other. So you think about your weight distribution across these cavities. That'll apply to your dimensions. Also, a tonnage required to process these parts. This is a lower pressure approach, right? We're using pressure to control the pack phase rather than velocity in these family tools, in these unbalanced cavities, because pressure is sensitive to the geometric changes and imbalances in those systems. So, hope that makes sense. Thanks for joining me for today's video. Should have another one coming out soon. Thanks again. See you all next time.